Wonderful topic, excellent protocol by Cisco, a routing protocol by Cisco, which is EIGRP, Enhanced Interior Gateway Routing Protocol. Enhanced Interior Gateway Routing Protocol. Now, this is a wonderful IGP protocol. The protocol which forms group, we call it as autonomous system. Yeah, EIGRP will not work without that setup called autonomous system. It needs group of router with the same ID in order to form neighbor and to distribute the routes. Enhanced Interior Gateway Routing Protocol works in group. As a result, avoid unnecessary distribution of route information. If you take a RIP, there is no grouping system there. So, when a multicast traffic 224.0.0.9 RIP version 2 uses multicast 224.0.0.9 and RIP version 1 uses broadcast 255.255.255.255. In that, when an update is sent, all router will open it and then see it and then they drop it because the traffic don't belong to them. They are not running RIP. Whereas in EIGRP it is not like that. They won't receive it if they are not a member of same autonomous system. They first form neighbor. See, RIP never forms neighbor. So it keeps sending the update every 30 seconds using that multicast address and broadcast address. But EIGRP is not like that. First of all, it has to form neighbor. For that, autonomous system should be same. And only to the neighbor, EIGRP sends update. This also uses multicast address 224.0.0.10, but it is sent only within the same autonomous system member. EIGRP send updates to the established neighbor, not to anyone. It's only to established neighbors. 1 minute. See, this protocol is an excellent design. It forms first of all a group, so it knows with whom the update need to be shared, and to that neighbor only the updates are shared. So it's a very controlled environment, not simply randomly sending to a multicast address or a broadcast address all the route update. That's not safe. So EIGRP is really a safe protocol compared to RIP. In fact, OSPF also forms neighbor, BGP also forms neighbor. It is a safe environment. But EIGRP is not forming multiple areas. EIGRP supports you to form only a group, one group, which is called autonomous system. So that autonomous system with multiple routers is identified with a number. That is what we call as autonomous system number. That can be any number between 1 to 65535. And it is our wish to use number, but you need to use the same number on every router. Only then they form one common group. Next is the autonomous system may be of any size up to 255. See, normal distance vector protocol like RIP, they don't support more than 15 hop. But this one is also a distance vector, but we call it as advanced distance vector. One reason is it forms an autonomous system and then distributes the route. The other reason is it supports more hops. Up to 255 hop EIGRP can support. See, EIGRP metric is not hop count. RIP metric is hop count. EIGRP metric is bandwidth and delay. We will talk about that in some time. But EIGRP also has got some limitation with the hops. It cannot support unlimited hop like OSPF. OSPF unlimited hop count support. Because you can create multiple areas, the number of hop is not going to be a restriction. But this EIGRP forms only one big cluster, one big group called autonomous system. So you cannot simply have millions of routes and thousands of routers. No. There is a limit. And an autonomous system can have up to 255. The default number of hops that EIGRP supports is 100 only. 100 only. But it can go up to 255. Next is convergence. EIGRP is fast in convergence. Compared to RIP, this is faster. The moment the change occurs, the change will be triggered so that EIGRP can take the backup path from the topology table. Yes, EIGRP maintains a table called topology table in which you will have both primary and backup path. Primary and backup path. Yeah. So using the backup path, it can immediately push the packet when a primary path goes down. In that way it is fast in convergence. Whereas RIP, when the primary path goes down, there is no backup path. They have to discover the backup path and then only they will send the update. That takes time, that takes time, that takes long time. Okay. So it is fast in convergence than the other distance vector protocol RIP. Why it is fast? Because it maintains topology table. What is there in the topology table? Backup path. Third is, it's a classless routing protocol. It supports VLSM. It supports discontiguous subnet. Yeah. What is discontiguous subnet? Same subnet scattered here and there. You see here 10, network of 10. It is scattered 10.3, 10.1. This is what discontiguous network, 10.2. Subnets of same network scattered here and there. Because it is a classless routing protocol, it can support VLSM, it can support discontiguous subnet. This is what we see in our today's network. Everywhere subnetted networks. Not everywhere you see classful, mostly it is subnetted, classless. EIGRP is a very good protocol for classless network. Next is partial update. Don't send complete update, it sends partial update. Meaning, whenever a change occurs, only the change is updated, not the complete routing table. That's not the case with RIP. RIP has to send the update every 30 seconds whether there is a change or not. Here, the updates are not sent periodically. The entire routing table is not sent every time. Initially, they share the entire update, after which only the changes are updated. See, very big difference, no? RIP sends every time the complete routing table, 30 seconds, every 30 seconds they send it. That is going to consume bandwidth as well as the CPU of the processing router. Every 30 seconds, if they need to process the same information, then it is a waste of processing, you see. Partial update, when you send, only the change need to be processed. Next, support for multiple network layer protocol, meaning multiple network layer. What is network layer? Layer 3. What is the protocol in layer 3? IP, IPX, IPv6, Apple Talk. These are all the network layer protocol. See, you don't need to worry about the other network layer protocol. You need to focus only on IP and IPX. Sorry, IPv6. EIGRP has got a dedicated module for all this network layer protocol. EIGRP has got its own dedicated module. For IPX there is one EIGRP. For IPv6 another EIGRP. For IPv4 another EIGRP. For every network layer protocol we have a separate dedicated module. Okay. Next, flexible network design, meaning there is no restriction like 15 hop only I will support. No, you can have of any size, like up to 100 hops. You can have 10 routers, you can have 20 routers, 40 routers in an autonomous system. It is a flexible network design. As I said, if you want to have 150 hops, you can have it, but you need to go and change the max hop. By default, max hop is 100. You can tune up to 255, I told you. So you can have flexible network design. Next is, there is no broadcast, only multicast and unicast is used in EIGRP communications. When it sends a hello packet, a multicast address is used. When it sends an update, a unicast is used. So there is no broadcast. Broadcast is bad. That is why EIGRP don't support broadcast. Next is the summarization. You can do manual summarization at any point. We'll talk about that when we go there in detail. Next is 100% loop-free classless routing. Yes, EIGRP uses an algorithm called dual, diffusing update algorithm, dual. Because of that algorithm, it can guarantee 100% loop-free in a classless environment. Configuration in LAN and WAN both are similar, so it is easy. There is no complicated configuration for WAN and easy configuration for LAN. For both LAN and WAN, it's the same configuration. Okay, so it is easy. Load balancing across equal and unequal cost path. By default, it supports equal cost path. You can tune EIGRP using variance command. We'll talk about that later in detail, which makes EIGRP to support unequal cost path. Load balancing across unequal cost as well as equal cost is available. We will be seeing these things in detail in coming class. This is the good introduction for EIGRP, and hope you will enjoy this EIGRP journey for next couple of weeks. We'll stop here today.